All right, so today's, again, we're starting unit 2, okay? 2 of the 3 that are on this one's got 15 units, or 15 sections in it as well, that are on, so we'll go, this will literally, unit 2 will take us until we hit Christmas, basically. And then we'll do unit 3 when we come back from break. So 2.1 is called change in arithmetic sequences and geometric sequences. So a sequence, by definition, is an ordered list of terms. Literally, in math sequences, it's just a list of numbered terms, okay? There are 2 different types of sequences in general, and they are finite or infinite. What's the difference between those 2 words? Good. One stops, right? One has a limit, and one doesn't. So a list that could be finite would give you like a specific number of terms, like 1, 2, 3, 4, and it stops. That's a finite sequence. But when you see something like this, like the 1, 2, 4, ... that implies that sequence goes on forever. That would be an infinite sequence, okay? And these are graphed as individual points because these are like your stat plot dots. And that is a super important phrase because that is the difference. We're eventually going to learn that an arithmetic sequence is very much like a linear function and a geometric sequence is very much like an exponential function. But the difference between them is that sequences are dots on a graph, whereas a linear function is clearly a line, okay? So if I was to compare, if I wanted to plot a sequence, it would look something like this, whereas obviously a line looks like that. It's a difference between sequences and functions, okay? Functions are going to be smooth, continuous, and sequence would be literal dots. There are 2 types of sequences that we're going to talk about, and they are arithmetic and geometric. Arithmetic, sequence is arithmetic when the difference between consecutive terms are the same. So it has a constant rate of change. So if you think about what else has that same behavior, it's a linear function. A linear function has a constant rate of change. The change from one point to the next is the same as the second point to the third, and so on and so forth. The difference in an arithmetic sequence is called the common difference. So if I have, for example, a sequence that's like 2, 4, 6, 8, what's changing every time? Like, what am I adding or subtracting to go from 2 to 4 and 4 to 6 and 6 to 8? You're adding 2 each time. So this is an arithmetic sequence in which your common difference, and the variable we use for difference is d, would be a positive 2. If I went the other direction, if it was 8, 6, 4, 2, now what's d? Negative 2, okay? So no matter which pairing you pick, okay, I could go from 8 to 6 or 6 to 4 or 4 to 2. The common difference stays the same. So example 1 says, determine whether or not the sequence is arithmetic, and if it is, find the common difference. So we're going to simply subtract the second minus the first, the third minus the second, and so on and so forth. So 4.3 minus 3.7 gives you what? 0.6. Then 4.9 minus 4.3 gives you 0.6. Then 5.5 minus 4.9 gives you 0.6. And 6.1 minus 5.5 also gives you 0.6. So is this arithmetic? Yes. And the common difference is 0.6. If just one of those didn't work, obviously it's no, and that's why we check them all. All right, so now we're going to use this information to find an equation you can use to find any term in this sequence. So it'll say find the nth term, or find an equation used to find the nth term, which means any term in my sequence. Yeah. Sure. And the parent form, or the original function, is this. A sub n, which means any term in this sequence, equals a1 plus d times n minus 1. So for that original equation, I need A1, which is the first term in my sequence, and I need D. So I will plug in A1, I would plug in D, and I would get the equation of my arithmetic sequence. Now, since an arithmetic sequence is like a linear function, these will be similar to a y equals mx plus b. These are just going to be equations of a line. But you don't always have to use A1 to start, okay? So this is your generic one, but if the directions say use K, it gives you it as K, like use K is 0. That means I want my first term to be A0. And what gets adjusted is the initial term and what you're subtracting from n. These two should be the same number. So if you start with A1, you're subtracting 1. If you start with A0, you're subtracting 0. If it says give the equation where K equals 2, then I would start with 2, so I'm going to subtract 2. So whatever the bottom, the subscript number is on your term, so your A whatever, is also what you're going to subtract from n. D is your common difference again, and it says A1 is the first term of the sequence. Yep.
On that last equation, what is like A called? Is there a specific?
What is A called?
Yes.
No. It's just A is any term, like A sub n is any term in your sequence.
Okay.
Yeah, so n is like, use this equation to find any term,
Okay.
not a specific one. Does that make sense?
Yeah.
So it'll usually ask, you'll see, it'll ask you to find A sub n for the arithmetic sequence. So you're coming up for the equation. So unless it says where K equals 0, because I'll show you like that's on the homework, or where K equals 2, then we always use our original A sub n equals A1 plus D times n minus 1. So go to A. You have A1 and you have D. Those are the two things you got to plug in. So AN equals 100 plus a negative 8. So this is going to become minus 8 times n minus 1. So that's one way to express this equation. Sometimes in these types of questions, it will say, which of the following could be used to express this sequence? And that's one way. The other way would be to keep going and distribute your 8. So I'd get AN equals 100 minus 8N plus 8. And combine your like terms. So I'd get 108 minus 8N. So this equation can be used to find any term in the sequence, but so can this. And again, notice your exponent is raised to the first power, so this would be linear. Okay, so now go to B. So what two things do we plug into these equations? A1 and the common difference. Do you have A1 for B? What is it? 4. 4 is A1. Do you know the common difference yet? No. Can you find it? Yeah. Pick any two. Literally pick any two because it doesn't matter which two. What do you think is the easiest to find the difference between? You could do 3 halves minus 4, or you could do negative 1 minus 3 halves, which is negative 2 halves minus 3 halves, or negative 5 halves. So you could pick any two, consecutive, not like 4 and 1. They have to be consecutive, but it can be any of them. So then this is D. So AN equals A1, which is 4, minus, because it's negative, 5 halves, n minus 1. 100.
How can we be sure it doesn't change?
How come what? It will, if it says find a rule for the arithmetic sequence, you know it's an arithmetic sequence. If the question first said determine if it is, now you got to test it and then use it. Good question. All right, so then I'm going to distribute that 5 halves. So this is one answer, okay? But A sub n can also equal 4 minus 5 halves n plus 5 halves, which becomes 8 over 2 minus 5 over 2n plus 5 over 2. And then I'm going to combine these like terms. So an equals 13 over 2 minus 5 over 2n. So two answers to represent the same arithmetic sequence.
I don't get why you did an extra one. Because know
I just distributed this. So you're simplifying the equation.
Okay, so you never really finished it.
What do you mean?
You never finished that.
Well, this is an acceptable equation to find a term in the sequence. But you could also say that this is also an acceptable way to find. So you'll see there's questions that say, which of the following work? And it's more than one. Or if it's multiple choice, you'll see one but not the other.
Okay.
And you'll have to know to do both.
All right.
Yeah.
So do you have to have both?
No. No. If it's open-ended,
Then
you can just choose one. Correct. Yep. That was your question? Yeah.
For the question, the type of question that you said would be like, which of the equations work? If we got one, like the first one, will we have to solve that out to be able to figure out if any of the other ones
Usually.
apply?
Yeah. All right. Example 3. Now it says 2 terms of the arithmetic sequence are given. Find the missing term. So for the only one that's on here, it says A1 equals 8 and A4 equals 17. And you want to find A8. So let's think about how we could do this. If I use the equation AN equals A1 plus D times N minus 1, for example, okay? What information do you already have? A1. What information are you missing? D. How could you find D if an arithmetic sequence behaves like a linear sequence? Could find the slope. So technically, good job. A1 equals 8 and A4 equals 17 are 2 coordinate points. Does that make sense? This is really 1, 8, and this is really 4, 17. So the common difference is the same as finding the slope of a line that would connect those points. If I wanted to find D, I could do 17 minus 8 over 4 minus 1. And I get 9 over 3, which is 3. So now I have A1. So AN would equal A1, which is 8, plus D, which is 3, times N minus 1. And the goal here is to find A8. How would I find A8? Plug 8 in for N. So 8 plus 3 times 8 minus 1, 8 plus 3 times 7, 8 plus 21, which is 29. So any 2 terms in arithmetic sequence work just like coordinate points. And if you wanted to find your rate of change, it's the same as finding slope. We good so far? Okay, now we get into geometric sequence. A geometric sequence is one in which the ratio of the consecutive numbers are the same, meaning we multiply each term by the same number to get the next term. A geometric sequence behaves very similarly to an exponential sequence. So if I were to plot an exponential and a geometric sequence on a graph, a geometric is going to increase quickly like that. It's going to be one fluid curve, whereas a geometric is going to be dots that behave in the same way, okay? So geometric dots, exponential, a curve. So now we're multiplying the same number each time, and that same number is called the common ratio, and the variable we use is R. So common difference is D, common ratio is R. You with me so far? Okay. So example 4, determine whether or not this sequence is geometric. So 3, 12, 48, 192, okay? You could literally go take term 2, divide it by term 1, and term 3 and divide it by term 2, and term 4 and divide it by term 3. Or spot a pattern. So if I had to go from 3 to 12, what am I multiplying by? 4. So then is 12 times 4 48? Yes, and probably not something we know off the top of our heads is 48 times 4. 192? Yes. So yes, this is geometric. If it didn't ask for it, but if it had asked for R, it would be 4. Yep.
Is arithmetic, so geometric, you can always find it if there's a common denominator, you can multiply by.
Right.
So,
You're multiplying by the same thing each time. But then, like, if you look at B, when you start to get into fractions, obviously it's not as easy to try to spot what it is. So then to check, we divide the second term by the first. So 1/2 divided by 1 is what you would be doing. Or 1/3 divided by 1/2. And then 1/4 divided by 1/3. So it's the one that precedes it, you're going to divide by, okay? 1/2 divided by 1 is what? 1. 1/3 times this becomes 2/1 is 2/3. Those are not the same thing. This is a no, okay? Because R is not the same. On the next one, it's 3/4, right? It's definitely not the same. So second divided by first, third divided by second, fourth divided by third. As soon as you get two that don't match, though, stop. The answer's no. Still good? Okay. And now they're going to do the same thing we did before. Here's a term, find the equation. Oh, no, sorry, this one says first find the first 5 terms. So if I've got term 1 and I've got R, how would I get term 2? Multiply it. So 1 times 1/2 is 1/2, and that is term 2. And then term 3 is 1/2 times 1/2 again. So it's 1/4. And then term 4 is 1/4 times 1/2, which is 1/8. And then term 5 is 1/8 times 1/2, which is 1/16. So when it asks for the first 5 terms of the geometric sequence, A1 is 1, so I start there. 1, then 1/2, then 1/4, then 1/8, and then 1/16. And order is important. So the second equation, so we need to know the nth term for an arithmetic, which is A1 plus D times n minus 1. And then you need to know the nth term for a geometric. So an equals A1, this time we multiply, so times r to the n minus 1. And that is r being raised to the power of n minus 1. And just like with your arithmetic, I can tweak it. So if I have A1, my exponent is going to be n minus 1. But if I use A2, my exponent is n minus 2. If I use A3, my exponent is going to be n minus 3. If I use 0, my exponent would be n minus 0. So depending on what term you start with, if it said k was 5, then I would say A sub 5 times r to the n minus 5. Yep.
did you see that the first term we have, the 0?
First term is A1.
Then what's 0?
A0 would be before the first term, which sometimes you got to find. You just got to work backwards.
So what would that be though? Like,
So if my first term, let's say A1 is 5 and R is 2. I don't know why I made it hard, but let's just say that, right? Moving forward, I would multiply by 2, right? So A2 would be 10. And then, but moving backwards, we divide by 2, which would mean A0 is 5/2. You're welcome. Does that make sense?
Yes.
Okay, good. All right, example 6 says find a formula for the nth term of the geometric sequence. Wait. All right, so now example 6 says find the formula for the nth term of the geometric sequence, then find the indicated term of the geometric sequence. So I'm going to do an equals A1 r to the n minus 1. So it's giving you 3, 36, and 432, and it wants the 7th term. So I have A1, right? A1 is what? 3. And I can find D. What is D? 12. D is 12 because 36 divided by 3 is 12. So it's 432 divided by 36, but you don't have to do that math because 36 divided by 3 is easier. So now any term in this sequence can be found using 3 times r, which, this should not be D. This should be r, sorry, which is 12 to the n minus 1. I lied about the calculator. You have to use your calculator on this one. Okay. So here's where you have to be careful. And when you do these, that n minus 1 is only on the 12. It is not on the 3. So we don't multiply 3 times 12 and then raise it to the power. You raise 12 to the power and then you multiply it times 3. So if I want to find the 7th term, it's 3 times 12 to the 7 minus 1, which would be 3 times 12 to the 6th. If that's a manageable number, you might not have a calculator for this question, but obviously I don't expect you to know 12 to the 6th off the top of your head. But if that was like 2 to the 6th, this could be a non-calculator question, okay? All right, so 12 to the 6th is 2,985,984, and then I multiply it times 3. And I get 8,957,952. 8,957,952. Now, if you didn't know how to find the equation, it asked you for the equation this time, but if you didn't know how to find the equation, how else could I have gotten to the 7th term in this sequence?
Keep multiplying by 12.
Keep multiplying times 12 until you get to the 7th one, right? So should you forget, that is also an option. But normally, if it wants you to get the term, it's going to do both. Find a sub n and find the term.
Why does it say 7th term?
That's the term it wants you to find.
Oh, but
Yeah.
But 3, 36, and 4, 36
Are the first 3 terms in the, yep.
Like the cold.
Yep. All right, example 7 says find the indicated term of the geometric sequence. So similarly to what we did with arithmetic, you're given a gap, right? You get the first term, but you don't get the fourth until the 4th term. So we're missing terms in between. Here's what you can't do, find slope, because does an exponential function have the same kind of slope as a linear does? No, an exponential function does not have a constant slope. Does that make sense? So we can't just do y2 minus y1 over x2 minus x1, okay? So here's the trick, and I'm going to teach you because I think it's the easiest way to do it, but I would say make sure you're paying attention, okay? When you skip terms, okay, you're going to set up your equation in a pattern in which a to the bigger base is on the left. It's going to equal a to the littler term times r to the big minus the little. We're going to do it a couple of times, but hopefully this makes sense, okay? Because we're not multiplying by the same term each time. We're not adding the same term each time, which is what it would be if we're linear. We're multiplying it. So when you're multiplying, and then you're taking that and multiplying, and then you're taking that and multiplying, you're raising it to the power, which is why that comes in, okay? So I'm talking, when I say big and little, of the base on these terms. So I've got A1 and I've got A4. Which one's got the bigger base? A4. So A4 is going to go on the left. And then A1 is going to go on the right. And I'm going to multiply it times r to the power of 4 minus 1, which is 3. So now we're going to plug in what we know, which is A4 is 1/2. A1 is -4, and I don't know the r to the third. So then how do I solve for r to the third? Well, isolate it, right? So divide by -4, which is the same thing as multiplying by -1/4. So this is gone, and I get r to the third equals -1/8. And then, if it's r cubed, what do you do to get rid of it? Cube root it. So I do the same thing over here. Do you do plus minus when you cube root? No. So what is the cube root of -1/8? -1/2. Good. Okay. So I did all that to find r. So now I plug it into the initial a sub n equals a1 r to the n minus 1. So a(n) is any term in the sequence. A1 is -4. R is -1/2. And the exponent is n minus 1. Now that can be used to find any term in my sequence. Which term am I looking for this time? The 10th term. So I'm going to do -4 times -1/2 to the 10 minus 1. And I get -4 to the -1/2 raised to the 9th. Now, these answers are typically kept exact, so be careful and don't take that in the calculator, plug in -1/2 and raise it to the 9th. You can separate it out. I could say -1 to the 9th is -1, and then 2 to the 9th is 5/12. But you don't want to make that a decimal. You want to keep this exact. And then 4 goes into 5/12 128 times. -4, -1 over 5/12 makes it a positive 1 over 128. You could have also taken your fourth term and multiplied it times your r, which is -1/2, until you get to the 10th term. If you're looking for like the 5th term, that's easier to do, right? If I only need to go from the 4th to the 10th, or the 4th to the 5th, as soon as I find r, I just have to multiply it once. But the bigger the gap, the more work that's going to take. We still good? Okay. See if you could set it up to find the r. So almost the same type of question. The biggest difference is what don't you have this time that you had the last time? A1. But can you find the equation even if you don't have A1?
Yes.
Yes. So set up your big little to solve for r, and then we'll go from there. So how are you going to set up your initial one? Like before we plug values in. A what goes on the left? A5 goes on the left. On the right? A2. What's r got to be raised to? The third. Good. So A5 is 2/3. A2 is -18 times r to the third. I want to divide both sides by -18. So I'm going to multiply by -1/18. 2 goes into 18 9 times, and I get r cubed equals -1/27. So then I cube root both sides. And r is, what's the cube root of -1 over 27? -1/3. Good. So now I have really three options. I could say an equals a2 times r to the n minus 2, and I could plug my values in there. I could say an equals a to the 5th times r to the n minus 5. I could plug my values in there. Or I only have to go from the 5th to the 6th term. So what's easier? Just multiply it by the r once. So I'm going to take my 5th term, which is 2/3, and multiply it times -1/3. And I get -2/9. So any of those three methods would have worked. On this one, it would have been -18 times -1/3 to the n minus 2. On this one, it would have been 2/3 times -1/3 to the n minus 5. And then you could plug in 6 to either of those. Or you just only have to go one unit, so you just multiply. We good? Okay. Last slide says find an equation that gives the nth term of each sequence. Instead of the initial value, use the kth term of the sequence in your equation. So notice it's telling you, I don't want A1, I want you to use A2 here. And I don't want you to use A1 here, I want you to use A3 here, okay? First of all, does it tell you which kind of sequence? No, so how are you going to figure it out? How would you know the difference between arithmetic and geometric? Look at the change. Am I adding the same thing each time in A? Definitely not. Or subtracting the same thing? No. When I divide them out, are they the same? Is 20 over 50 the same as -10, or sorry, it should be 20. Just kidding. 50 minus 30. I was going to say it doesn't work the other way either. 50 minus 30, 20 minus 30, -10 minus 30 tells you D is -30. So it's arithmetic. So now, if I set up my original one, it would be AN equals 50 minus 30 times n minus 1. But is it asking you to use A1? No. What does it want you to use? A2. So AN is going to equal A2 minus 30 times n minus 2. And what is A2 in this sequence? 20. So this is AN equals 20 minus 30 times n minus 2. And that format is fine unless it's multiple choice and you see it distributed out. Or it says list all the ones that work. So in that case, I would do 20 minus 30n plus 60, which is 80 minus 30n. Yeah.
Do we know that it's arithmetic because it's not A1 equals an A?
No, it's arithmetic because you're adding or subtracting the same thing each time.
But we just, how do we know that we can't divide by something?
You could try it. 20, that's what I mistakenly was doing. 20 over 50 is 2/5. Negative 10 over 20. First of all, the sign doesn't even alternate. If the sign doesn't alternate, something's wrong. You can't multiply, right? If the sign alternates, you're multiplying by a negative number. Does that make sense? Okay. All right, so go to B. Arithmetic or geometric? Geometric, right? You're not adding, you're adding to the first one, but then you're adding 4, so that doesn't work. But 4 divided by 2, 8 divided by 4, 16 divided by 8 are all 2. So my R is 2. Because I want the third term, I'm doing AN equals A to the third times R to the N minus 3. So AN equals A to the third is, or A3 is what in this sequence? 8. R is 2 to the N minus 3. So when it asks for K being 3, that's what it means. Now, we talked about it before, but if this said K equals 0, do you already have A0? No. What would you have to do to get A0? You'd have to go backwards. So if we're multiplying by 2, we'd have to divide by 2. So A0 and this would be what? 0. Okay? And if I wanted A0 on the first one, okay, if this is my A1, what would be A0? 80, good. You'd be adding 30 because we're going the other direction. God bless you. Questions? Yeah.
For the first one,